Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using 9. In this chapter we're going to cover the mean and variance, the measures of central tendency for random variables. Just like variables from a data set, random variables are described by the measures of central tendency, the mean, and the variability, the variance. In this chapter, we're going to discuss how to compute these measures with discrete random variables. The mean of the discrete random variable x is also called the expected value of x. Now, notationally, it's going to be written as e with left parenthesis x inside. Use the following formula will actually demonstrate for you. The expected value of x is equal to the mean of x, which is equal to the sum of each value of x times the probability that that value of x will occur. All right, look at an example here. A recent Little League softball game, a probability distribution chart on the left, shows the likelihood of an individual player getting a hit. What is the expected mean of a player getting a hit? Well, remember the mean is the sum of each value of x times its probability. So the sum of 0 times 40% plus 1 times 30% plus 2 times 20% plus 3 times 10%. The sum of all those is 0 plus 0.3, 0.4, and 0.3. So the sum of those is equal to 1. Now the variance for the discrete random variable x is notationally variance of x, VAR with x in parentheses. The equation for computing it is a little more complex. It's the value of x minus the expected value of x squared times the probability of x. Let's continue our Little League example and find the variance for the probability distribution. The formula is going to be the value of x minus its expected value squared times the probability. Refresh memory, the expected value of x was equal to 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. The expected value of x is 1. So, to compute the variance, we're going to say 0 minus 1 squared times 0.4 plus 1 minus 1 squared times 0.3 plus 2 minus 1 squared times 0.2 plus 3 minus 1 squared times 0.1. So our expected variance is going to be equal to 1. And just a note, we've been talking about discrete random variables. For continuous random variables, you can compute the mean and the variance as well. However, it requires a calculus formula, which is well beyond the scope of what I'm teaching in this class. That completes this chapter of the class. Feel free to move on to the next chapter.